Hello and welcome to the solutions for the second part of chapter 2. What I've got on the screen here is problem 19. So problem 19, we had some data that had some waiting times for patients with tracking and some without tracking. And so what I wanted you to do is actually compute the means. I'm looking for, did you use the function? Most of you used the function and did fine with that. Others of you may have just typed in numbers, and that leads me to suspect you may not know what's going on and you got some help with somebody, you saw their answers, typed them in, and that was it. So please make sure you know how to do these calculations. So the average, you can use the median function. Uh, you can actually calculate out the standard deviation using a function as well. Notice that this is for the sample size, not the population. You don't want the population because you don't have the entire population of all patients. And then you can also do the same thing, and then you square that to get the variance. Then for part C and D, I was looking for a graph that looks similar to this and that you had proper labels on it. So this is one without tracking, and if we scroll down just a little bit, you see the one with tracking. So again, there's more variation here, there's less variation here. And so then for part E, what you would want is the wait times for patients with the wait tracking system are substantially shorter than those for patients without the wait tracking system. For problem 20 then, I'm looking for some information in terms of, did you use the median function? And what I was looking for there, I'll move this up so you can see it. Just basically this median here. And did you use the correct range? Then, so did you have the correct numbers? 54 for science, 47 for English. Then you did your box plots, and you would look for something similar to this. So science has little variation, but a high number out to the side here. If we scroll over here, this is what the English one should look like. And most of you did a fairly good job on that. Some of you didn't do the box plots, and so you lost a half a point each on those. Then for part E, what I was looking for is that the box plots show that the science teachers spend more hours working per week than English teachers. There was a couple of you that put them side by side but didn't pay attention to the numbers you had over here. So the science teachers, you can see it's above 50, and the English teachers, it's right at the extremes here, below 50. So you got to pay attention to what your numbers are showing you. And that's what I was looking for on problem 20. So what I've got on the screen now is problem 21. So you're going to go back to the data that you have in problem 19. So basically you copy the data over again and then you answer the questions. And so it's asking you for the z-score for when you have 37 minutes here, or the 10th patient. So the number I'm looking for is 0.48, or this 0.47. So we haven't gotten into rounding yet, but you probably only should report 2 decimal places. So you could calculate it out, or you could use the standardize function. So the number we want to standardize is 37. So that's where the A11 came to. The mean was 29.1 and the standard deviation was 16.602. Remember, to calculate out that z-score, it's the value minus the mean divided by the standard deviation, and that automatically does this for you. So that's what I was looking for. In part B, it's asking for the z-score for the 6th patient in the sample that we can just click over here and you can see it's 37 again. But now we have a much higher z-score. And the reason for this is that you're now got a sample that's with weight tracking system of a smaller mean and a smaller standard deviation. So as you're subtracting less, which means you're going to have a bigger numerator, and then you're dividing by a smaller number, which means it's going to make it larger. So you have to think about what your numbers are doing and your calculations are doing. So I just calculated it out, and so again we can see that we've got B7, which is this value minus the mean divided by the standard deviation, gives us this formula. Notice I put parentheses around the part in the top, which is the numerator, and it gives me the exact same value as our standardized function. The last part of this problem asks if there are any outliers. And the outliers are determined if you have a plus or minus z-score greater than 3. So you need to calculate the z-scores of everything. And you can see that's done over here. And there are none with a greater than 3. So that's what I was looking for. So you need to understand plus or minus 3 deviations there, or z-scores I should say, in order to be an outlier, and that's what I was looking for. The next problem is problem 23, and so keep in mind this tests your understanding of the empirical rule, and the empirical rule can be found at the page 52. And so what that means is, what it says is, if you have a normal distribution, that if you look at your standard deviations, what proportion of your results should be within those standard deviations. And it says for the first standard deviation, you should have 68% of your data values. For 2 standard deviations, you should have 95% of your data values. And almost all your data values will be within 3 standard deviations of the mean. Right? So sometimes it helps to visualize that. So I would suggest that you draw a bell-shaped curve, and I'm going to try and get a marker out here and do that for you. Wrong pen. Hold on. Alright, so we have a bell-shaped curve, something like this. Alright, so in the middle, that represents the mean, right? Scroll down a little here so you can see it all. Try to draw an X bar here for you. Okay, so according to what you're given, 515 is the mean. So what is one standard deviation? So one standard deviation above and below the mean should have 68%. So we'll say this and this, and just so we know, this is the mean. All right, so this is above the mean, this is below the mean. So this value right here is 615, and this one is below the mean, so that's 100 less, because it said the standard deviation is about 100. So this one would be 415. So what that means is that this area here is 68%. Okay, I'm going to change colors here. All right, so that's all of this area. That's 68%. Okay, so question A says, what percentage of students have an SAT math score greater than 615? Well, if this is 68%, then how much of this area is left? So that's 100% minus the 68%. If we can see it up there. Which would be 32%. So, but that 32% is split on both sides of this distribution. So that means that 16% must be here, and 16% must be here. Okay? So A is 16%, so anything greater than 615 is 16%. What percentage of the students have an SAT math score greater than 715? Well, 715 is another standard deviation out since it's 100. So let me change the color here. And we'll go with green. So another portion out. So now all of this, according to the empirical rule now, is 95%. Okay? So let me just write that in here. And I hope you're taking better notes than what I can draw on the screen. So, but that also means that right here, that's 715. Okay, and this number would be 315 because we're two standard deviations away from this mean. So this is 95%. So that means what's left over is 5%, but that 5% is in each one of these little quadrants here. So that's the reason why we have to divide that 5% by 2, and that means there's only 2.5% right here that are above the 715, or 2.5% below the 315. So that's the answer to B. So C says, what percentage of students have an SAT math score between 415 and 515? So the calculation for part C is what percentage of students have an SAT math score between 415 and 515. So if this is the median, or mean rather, then we know that 50% of our data points are below it and 50% or above it for a normal distribution. So we got 50 here. And we know that after one standard deviation, the rest below it should be 16%. So we subtract that, and that equals 34% for what is left over. The calculations for the other parts, let me get out of this and see if I can do that for you. We just erased everything, but hopefully you can go back and watch that. So it's asking for what's the z-score for 620. So if we know equals 620 minus the mean, which is 515, divided by the standard deviation, we get a z-score of 1.05. If we want to change that for 405 and see what it is, you would do the same thing except replace the 620 with 405, and you get a z-score of minus 1.1. So keep in mind, this is just telling you how far away the value is from the mean, standard deviation wise. That way, we also know that if it's more than 3 in either direction, then we would consider that to be an outlier. For problem 24, I was looking for something like the following: a scatter plot that looked like this. You would tell me that it was a negative relationship for part B. Then for part C, you would give me the covariance using the correct ranges here, and then give me a negative correlation. And so that's what I was looking for. So again, make sure you understand what you're doing, and make sure you understand what the interpretation is. And so when you look at the covariance, then that negative covariance means that it's confirming there's a negative linear relationship between x and y, right? The correlation coefficient indicates a strong, let me click off of that, negative linear association between x and y. For problem 26, I want to look at and see if there is a correlation between the jobless rate and percentage of delinquent housing loans. What's your interpretation? So to answer this one, I was looking for the relationship there, and you should have a correlation relationship of 0.44, so it's weakly correlated. Then for part B, I was looking for a scatter diagram and should have something like this. For problem number 27, I was looking for your way of going about selecting anything that is wrong with the problem. So part A asks if there's any missing values. And so, yeah, some of you went through and just looked at your data to see if there was anything missing, but you can miss that. And so one function that's there to help you in case you've got those kind of missing values in Excel is to use count blank. So with count blank, specify the range of the column you're looking at, and then it'll tell you how many missing values you got. So here you can see if they did that, I was looking for something similar to this. This second column had a missing value, and this third column had a missing value. So I'm trying to align this for you. So we're not going to look and see if there's any missing values for respondents. So we've got, this is the 0 taste, we're okay. Texture, where you've got one missing value here. Creaminess of filling, sweetness okay, but depth of chocolate, flavor of the cup, we've got one missing value. And so that's what I was looking for there. So that's one thing you should be able to do. Then the next thing I wanted to see is, okay, can you spot a number that doesn't look like it needs to be there? And so I was looking for at least a couple, two or three. If you only provided one or said none, then I counted off for that. So you need to look a little closer, think about what kind of data is collected, and then you can spot those things if you'll lay out your averages. What are the averages should be, standard deviations. Again, if something's well below the standard deviation, or well below the mean by a couple of standard deviations, or above the mean by a couple of standard deviations, then something's probably amiss. So things you should have spotted or could have spotted were, like in the texture column, respondent 68, this big huge number. It's outside the range of the variable. The value of sweetness for a respondent 72 is 997. So even though you don't see it here, if you're looking at your numbers, you could spot that. And then small numbers, if you see something like this, 0.67, it's outside the range, and also what kind of data type it is. So if it doesn't correspond to the data type that's going in the column, there's probably a problem. It was entered incorrectly or something. And so that's what I was looking for. A lot better this week than last week. Go back and review things, understand that empirical rule, what it means, and we'll continue on.